Topic 2 is related to graph analysis. Sometimes the question will give you the f prime graph, sometimes it will give them the f graph and asking you to analyze a few things. We're going to start with the 2017 AP FRQ number 3. The question says f is differentiable. So every time when you see this word differentiable, you need to imply that f is also continuous. Differentiability is implying continuity. And this can be very, very important because we can use that in the later parts where they asking you to justify calculus theorems. And then on whatever this interval they are given to you, it is also giving you the one value, f of -2 equals 7. And it says the graph of f prime is given. This is the derivative graph. Again, you need to understand the relationship between the derivative versus the original f. And then it's asking you to do the following parts. Now, what I'm going to do again is I'm going to briefly brainstorm each part for you. And then if you understand how to do the problem, you can go ahead and try to finish the problem yourself and try the answer later by pausing the video, or you can just follow along. So in this first part is looking for the f value. Now by giving the f prime, we need to apply the first fundamental theorem of calculus, the antiderivative from a to b, and then you need to decide what a and b are. The integrand is f of x dx, that is equal to f of x evaluated from a to b. So again, this is just a little idea. We can come back to do the setup and solving later. On part B is asking for where the interval f is increasing. And this, I want to remind you a reference we have back in Unit 5. These are some of the topic questions AP exam will be asking you for. So you need to understand how to use the correct explanation and justification to do those justifications. Okay, so back to part B, we need to show f is increasing, which means we need to show f prime of x is greater than 0. For part C, we want to find the absolute minimum or the absolute minimum value. So when you see the absolute minimum or the absolute maximum, that reminds us to use the EVT, extreme value theorem. And then there's one keyword here says the value. This means the y value. So we have to be careful about those keywords. Sometimes the question is looking for the x coordinate. Sometimes they are looking for the y values. So here they are just, we have to be careful about what they're asking. And then part D is looking for the f double prime, which is the slope of the derivative. Part A, we are looking for f of -6, but the question is given f of -2. So when you set up the integral, the a and b, the lower bound should be smaller than the upper bound, so you should put -6 here and then -2 in the upper bound. The integrand is f prime of x dx. This is the accumulation from -6 to -2 of the f prime graph. That will, according to the first fundamental theorem of calculus, this will equal to f of b, which is f of -2 subtract f of -6. So this will be the final amount minus the initial value. And in this case, we are looking for the initial value, f of -6, and that will equal to the final amount, subtract the accumulation. Okay, so this is the steps they are looking for. You don't really have to write a very first step right here. This is I'm highlighting the part AP grade is looking for. But I recommend you to write the first part just to remind yourself what is the initial value with the final value and then the relationship between them. So here we need to do the calculations. So f of -2 is given to us, which is 7. And then the rest is the area under the curve from -6 to -2 f prime of x dx. So which means we are looking for, from here, this is the triangle, -6 to -2, right? Here is the accumulation we're looking for. The area above the x-axis is positive, and that is a triangle. So all we need to do is applying the triangle formula: 1/2 base times height. The base is 1, 2, 3, 4. The height is 2. And that is the work they are looking for on the AP exam. Don't write your calculation on the graph itself. You need to make sure you write the calculation in the parts, in the boxes. And in this case, it is 7 minus 4, which is 3. So here I might want to add f of negative 6 is 3. Okay, because we have two different questions they are asking. We also have f of 5. And we're going to do the same thing for f of 5. Now this time, the lower bound will be negative 5. The lower limit will be negative 2. The upper limit will be 5, f prime of x dx. Again, this step is not required. It just helps me to figure out how I can go from initial value to final value using the accumulation. And then we are looking for the final value itself, f of 5, which is the accumulation, either the initial value adding the accumulation or the other way around, doesn't matter. Okay, and then here the initial value is 7 plus the accumulation. And now all we want to find is the accumulation from negative 2 all the way to 5. And in this case, we are looking for this area of the semicircle all the way to 5, which is the triangle. Now I want to remind you, the area below the x-axis is negative, and then the area above the x-axis is positive. So we have a negative semicircle area, which is a negative half pi r squared. The radius is 2 in this case. So it will be negative 1/2 pi times by 4. And that will be the area for the semicircle, plus for the triangle will be 1/2 base times height. In this case, the base is 3, the height is 2. So the answer will be 10 minus 2 pi if you compute all the way. Now this question has 3 points total. Okay, we're going to move on to the second part. The second part, again, we already know that we're looking for f prime is greater than 0, f prime of x is greater than 0. And in this case, f prime of x is greater than 0 every time when you're above the x-axis. All of this part right here. So the interval we are looking for is from negative 6 to negative 2, and then from 2 to 5, and that's pretty much it. Now, technically, what happened here is at negative 6, the f prime of x is greater than 0. So here you can technically use a bracket. So here on part B, f prime of x is greater than 0 on these intervals. Try to write complete sentence on AP exams from negative 6 to negative 2, but you cannot use a bracket on negative 2 because f prime of negative 2 is equal to 0, not greater than 0. So here should be a open. And from the 2 to 5, both of those are going to be open parentheses. Now, if for some reason you wrote both for open, it is also counted correctly. So if you're not so sure, I will recommend you to use open intervals for this kind of justifications because it is right. This is a correct statement for that. The inclusion of the endpoints or not are accepted. So therefore, f is increasing. You can use the word during these intervals, and that will be good because then you can know the location. Here it will be awarded 2 points for the correct justification. All or nothing. On to part C, it's looking for the absolute minimum value, so we need to apply the EBT. To apply the VBT, the first thing we need to do is find the critical point, because the absolute maximum, absolute minimum are occurred at the end point and at the critical point. So first thing first, we need to find f prime of x equals 0. So according to our picture, which is -2, 2, and 5. And then we're going to use the candidates test. Here are the candidates, and then here is f of x. We need to figure out the y value, which is the original function value, including the endpoint. The endpoints are -6, and then -6 all the way to 5. So we already have 5 here. We need to include -2, 2, and 5. Those are the candidates. F of -6, we already compute that in part A. So here, computation is better for this question because you can know what is the smallest, what is the biggest. So sometimes safe stop may or may not help you. So you gotta just try to compute as much as you can so you can figure out which is the biggest, which is the smallest, which we need to use. F of -6 is 3. And we already also compute f of 5, which is 10 minus 2 pi. So those two are pretty much filled. And now we need to compute the rest. We know f of -2 already, which is 7. It is given in the problem. F of 2, we have to compute again the accumulation. So using our value that's given to you, f of -2, that's our a value. The b value will be 2 in this case, f prime. Again, applying the first fundamental theorem of calculus is f of 2, subtract f of -2. To find the f of 2 value, that is the final amount, we need to use the accumulation adding the initial. Now, accumulation is from -2 to 2. That is our semicircle under the x-axis. So therefore, this will be 7, the initial value, plus the negative area, 1/2 the pi r squared. So in this case, will be 7 subtract 2 pi. Now, which one is the smaller? 2 pi is about 6.28-ish. So when you do that, this is 7 minus 2 pi will be the smallest compared to the rest, because you're going to do 7 subtract 2 pi. So that is our minimum value, which is what they're looking for. Now we need to justify using the EVT. According to the extreme value theorem, we need to state f is continuous. Because the question says f is differentiable, then we know it is continuous. We need to state that f is continuous on the same interval by extreme value theorem. You're allowed to abbreviate extreme value theorem. F has absolute minimum value, absolute minimum value of 7 minus 2 pi. And if you want to state the x coordinate to be safe, you can do that at x equal 2. Now I want to remind you there is a possibility of multiple absolute minimums and multiple absolute maximums. And then if you have those values, you have to state all the locations of x for those absolute min and absolute max. Here are the points for part C, and then we're going to move on to part D. Since the question did not ask you to show calculations, you are allowed just to counting slopes. Since this line is a linear line, no matter where the point is, the slope is the same within the interval. So it looks like it's going down to right 4. So then you can just use our slope formula down to right 4, which is negative 2 over 4, or negative 1/2 if you reduce. If the question says show calculation, then you can use your slope formula, f of b minus f of a over b minus a. But in this case, your f will be your f prime of b minus f prime of a over b minus a to get the f double prime. For f double prime of 3, when you're looking at the curve, we see a sharp point, which means there is no derivative. But we need to justify the answer when the derivative does not exist. So to remind you, to show the derivative does not exist, we need to show that our derivative from the left of x equals 3 is not the same thing from the derivative on the right. You want to avoid using the word slope, so using derivative will be good. And then you can just use wording for this. When I'm looking at x equals 3 from the left, the derivative, the rate of change, is up 2 over 1. And I'm going to just write that. From the left of x equals 3, the derivative is 2. However, from the right of the same place, from the right of x equals 3, the derivative in this case will be a negative slope down 2 over 2, which is negative 1. Since the derivative from the left and then the derivative from the right is not the same, we can say that f double prime of 3 does not exist. Here is the point distribution for the last part. Next, we're going to look at 2019 FRQ number 3. This is a non-calculator FRQ. Now, I'm going to talk about AP timing for a second. You have 4 questions within a 1 hour AP timed, which averaged about 15 minutes per question. I'm showing you the scoring guideline first, and then you can use that to guide yourself to go through the problem yourself, and then time yourself to see if you can complete the problem within 15 minutes or less. And we want to find this antiderivative from -6 to -2. Now, keep in mind, we don't know anything below -2, so which means we need to use the properties of integrals to separate our definite integrals. So knowing -6 to 5 f of x dx can be break apart from -6 to -2 first, plus the accumulation from -2 to 5 f of x dx. And this part we can find by computing the area under the curve with the accumulations. Now, so therefore, our antiderivative from -6 to -5, f of x dx is going to be the antiderivative from -6 to 5, f of x dx, subtract the accumulation. Now that antiderivative from -6 to 5 is given to us. That will be 7. Subtract our accumulation. That's our setups. Now, to find the accumulation, we're going to compute a whole bunch of areas. Do not compute the area outside the boxes. You want to show all your calculation within our box. So here is going to be, I'm going to write the integral one more time. And then we're going to apply using safe stops here. So because we don't want to compute too much things. Just going to use the big brackets for all your calculations. We're going to start adding the triangle. This is above the x-axis is 1/2 base times height. And now this triangle is a negative triangle, so which means the area is going to be negative 1/2. The base is about 1.5. I'm going to write 3/2 here. And then you can write 1.5 if you want to. The height is 1. Now what we're going to do is we're going to add this triangle, because the rest looks like something being subtracted from the rectangles or squares. So this triangle here is a positive triangle. That's again 1/2 base times height. The base is 1.5 again, 3/2. The height is 3. So that's that triangle. And then the last one, we want to find this area under this curve, which I can use the square, subtracting our quarter circle here, which will give you this yellow area. So what we're going to do is add in the square. That's base times height, 1, 2, 3, 3 times by 3, which is 9. Subtract the quarter circle. The quarter circle is 1/4 pi r squared. The r in this case, it will be 3 as well. Part B is asking this antiderivative. Again, we can apply the properties of integral by separating this. This is the antiderivative from 3 to 5. 2 times f prime of x dx. You are allowed to put a constant multiplier outside the integrand, the integral symbol, and then plus the antiderivative from 3 to 5 for dx. Again, put it outside or inside really don't matter. We're going to integrate this anyway. Now, this part right here, the integrand is f prime of x. So if I take in the antiderivative for f prime, I will get f, which again, this applies the fundamental theorem of calculus. The antiderivative for f prime from 3 to 5 will be f of 5, subtract f of 3. Now, those are the y values on the curve that's given to us because we are given the f graph. Now this part, we can just use the antiderivative rules, plus the antiderivative for 4 will be 4x, and then we are evaluating that from 3 to 5. Again, you can just put a 4 out as a constant multiplier. Now the question here is also given to you where f of 5 is on the graph, that will be 0. The f of 3 value is something they are given to you right here, so don't forget to read the question detail. That is the value we're going to use. So here it's going to be 2 times f of 5 is 0, subtract f of 3 is 3, subtract root 5, that's the y value here, plus 4 times, when we evaluate this, will be 5 subtract 3. Now, again, this will be my safe stop. Part C is giving us a g function, the antiderivative from -2 to x, f of t dt, finding the absolute maximum value. Here reminds us to do the extreme value theorem. For finding the extreme value theorem, the first thing we need to do is find the candidates. One of the candidates is the critical value where g prime of x must be equal to 0. So here, the first thing I will do is apply the second fundamental theorem of calculus by doing the derivative of the antiderivative. G prime of x is f of x. That must be equal to 0. So where is f of x equal to 0? We know that it is over all the x-intercepts, which includes -1, 1/2, and then 5. And now we're going to complete our table by doing the candidate, and then g of x will be the y value. Absolute maximum we need to look for is one of the biggest numbers. So we're going to do all the work on the side. The endpoints are -2 and 5. The critical values are -1 and 1/2. So here, if I want to evaluate g of -2, all I need to do is plug in -2 into the x value for this integrand here. So according to our integral property, this will be equal to 0. The next one, g of -1, is the antiderivative from -2 to -1, f of t dt. We already computed that before. That is our triangle from here to here, which is 1/2. The g of 1/2 is the antiderivative from -2 to 1/2 f of t dt. So here I'm going to have a negative triangle. So here is the 3/2 times by 1 times by 1/2. It's a 3/4. Adding this triangle here, 1/2 minus 3/4, which we need to compute that because we need to figure out which one is the minimum value. This is -1/4. Now, g of 5, we technically already have that. That is the accumulation from -2 all the way to 5, which we did a safe stop in part 1. But here, we probably don't want to do that because we need to compute what this is to see if this is actually the minimum value or the maximum value. So if I compute that, to save your time, it is 11 minus 9 pi over 4 for all those calculations. That is actually the maximum value out of all of this. It's bigger than 1/2. Now we're going to use extreme value theorem. So this problem is looking for the absolute max of the g value, so we need to say the g is continuous. But how do we know g is continuous? That's because f is continuous and g of x is the antiderivative of f. We don't need to reason all of that. We just need to have to stay. G of x is a continuous function. I will include the interval because the interval is given to us on the interval -2 to 5. Therefore, by the extreme value theorem, g of x has a absolute maximum value of, another reason I want you to compute this is you can write much shorter answers, 11 minus 9 pi over 4. Again, to be safe, you can tell the AP grader where is it. It is at x equal to 5, the endpoint. Part D is asking you to evaluate this limit. To evaluating the limits, we can use direct substitution first. If that doesn't work and resulting with 0/0 problem, we might need to use L'Hopital's rules or other ways to find the limit itself. So we're going to start with the substitution. If I plug in 1 to everything, is that going to be okay? Now, if you are just plugging in, there is no need to do the limit notation. So this will be 10 to the first power minus 3 times f prime of 1, which is the derivative at 1 in my f graph, which again you can compute by using rise over run for the slope, over f of 1 minus arctan of 1. And then we need to compute those. F prime of 1 is the slope over here, which is up 4/2, which is 2. So the limit is going to be 10 subtract 3 times by 2 divided by f of 1 is the y value at this point, which is 1. You need to know what arctan of 1 is. We know tangent pi over 4 is 1, so therefore arctan of 1 will be pi over 4. And you can leave your answer like this.